Welcome to Rock Canyon in northern Utah, a spectacular canyon just east of the town of Provo that cuts through the Wasatch Range, the prominent mountain range here in northern Utah next to so much of the urban area. Thanks for joining me. I'm Geology Professor Shawn Willsey here in Rock Canyon, and we're here to explore what I think is a fascinating transition from one geologic unit and its story and depositional environment to the next unit above, which is a completely different environment and a completely different story. And I think that transition is fascinating. So let's go explore this together. So looking here to the east, you can see we have two distinctly different colored units. We have this darker unit down low, this sort of dark brown, kind of grayish unit, and then a really sharp contact right on top of this ledge here that transitions up into this lighter, more beige colored unit sitting up above. So let's take a look first at this lower unit, these rocks that make up this lowermost part of the canyon, see what they have to tell us, and then we'll go check out that transition over there. You can also see it across the way here, nice sharp transition. There's some rock climbers down there, but they're down there in that darker rock and then about to head up into the lighter colored rock. Let's see if we can zoom in there so you can see that transition right there. There's a nice view of that sharp contact between those two units. So let's go ahead and start with this dark colored rock, and there's actually a good outcrop of it right here in front of me. So I'm going to drop down off this ledge a little bit, get here on this slope, and take a good look at this unit here. So what we can see is this dark colored unit appears to be made out of particles of rocks. It's not crystals, it's actually made out of rock particles, and it looks like there's quite a few different particles that are embedded in this unit here. We've got these dark colored rocks by my hand. If we scan around a little bit, we can see some lighter colored little specks here, some other ones up here. So we have quite a bit of differences in terms of the size of the particles. Right here in this exposure, looks like they go down to essentially mud size, very fine particles, up to maybe, softball size or so, and there may be even bigger ones in here as well. The other interesting thing we can see in this rock is it does have some sort of fracturing going on here. Now, a lot of times it's tough to distinguish between what we call bedding, the layering we see in sedimentary rocks, and close fractures like this that can be caused by tectonic stresses, which is actually called rock cleavage. And so in this case, what we're looking at is rock cleavage. You can see there's actually some bands in here. So the rock, the compressive stresses and the other stresses with these rocks have caused it to sort of break along these lines here. But as we look at this in terms of these rock clasts in here, we really don't see any layering, no bedding. It seems to be massive. It's what we would say is a poorly sorted sedimentary rock. There's large particles and much smaller particles all mixed together. And it's quite a diversity of rock types. You can see one here. It's got these stripes running through it, kind of a nice attractive kind of golf ball size rock. This other light colored one here, that one looks to be a little bit quartz rich. So quite an assemblage of different rock types. So as we kind of finish up with our observations here, we might start to think about processes, interpretations, stories. Here's another large particle right here. And notice that the shape of the particles varies quite a bit as well. Some are somewhat rounded, others tend to look a little bit more angular with sharp corners and points to the individual clasts. So let's see if we can hop up here a little bit higher. Here's sort of a triangular particle here, kind of hidden in the branches, but you can see again, kind of a sharp point. It has some rounded sides to it, but it does look like there's some differences in terms of the overall shape of the particles. If we hop up here, getting a little bit higher in the unit, what we have up here is just a massive particle in the rock. I don't even know if I can get the whole thing in the frame. Let's see. So you can see the outline of it here. So this is maybe a meter or more in diameter. This looks to be a carbonate, maybe like a dolostone or a limestone. I didn't bring my acid bottle, so I can't really test it, but it's fine grained, and this sort of pitted nature of this surface here is very characteristic of these carbonate rocks, which can be dissolved by rainwater a little bit. So you can see it's kind of grooved and etched, and there's like little gullies and channels in the rock. But this is a massive rock. So as we consider what process might have deposited this dark lower unit that we're focusing on, we have to account for some sort of process that could transport rocks of this size. Maybe I'll head up here, maybe get a better view of it from the top. Yeah, that might be a little bit better here. Now you can kind of see the outline of the thing looking down on it. And again, about 3 feet or a meter or so in diameter. So what we have here is a rock unit that is from the Precambrian. It's about 850 million years old. And this very poorly sorted rock with large and small particles of different types of rock. There's no bedding, it just seems to have been massive. We need to think about processes that could deposit rocks of this size. I mean, in order to deposit something that large, you need a lot of energy. And it turns out these are actually glacial deposits. This is a unit known as the mineral fork tillite, and it crops out here and there in different places in northern Utah along the Wasatch Front. So this is our oldest story here. These lower units, this is the oldest rock here in Rock Canyon. Again, about 850 million years old. And the story of this rock is glaciers. And this was a period of Earth's history that I've talked about before and looked at rocks associated with this. This is a period known as snowball Earth. We see rocks of this type and of this age on all continents. And so even when we reconstruct the continents based on where they were in the past, we see that even at fairly tropical equatorial latitudes, we have glacial deposits. And so it suggests fairly strongly that the entire Earth, or nearly the entire Earth, was encased in ice. Again, this period called snowball Earth. So looking across the way, just to review again, we can see the tillite or diamictite, this dark unit with all the rocks embedded in it of all shapes and sizes. This sedimentary unit, 850 million years old, mineral fork tillite, is here. But let's go look now at the contact over here as we transition from this darker unit into the next unit above, which is much younger. Now we're going to fast forward time-wise from 850 million years to about 530 or so million years. So we're going to move forward almost 300 million years in time and see what these rocks can tell us about that period in Earth's history. So we're looking at the rocks now. Here's the bench right here with the darker rocks below, the ledge, and these lighter rocks up above. One of the first things I noticed here about these rocks is well, one, they're quite resistant. They're forming cliffs. In fact, we have several groups of climbers down below me that are ascending these cliffs. We can also see this unit is quite shattered. There are just fractures cutting through this rock every which way, and yet it's still, these fractures are quite thin, so the rock is still held together pretty well. It's still more or less cohesive, but this rock is quite beat up in terms of just being highly fractured and almost to the point where it's what we would call brecciated, where it's broken up almost into individual fragments. Let me see if I can get down to the contact zone here. So at other places in the Wasatch Front, we see this same unit here, and I suppose we need also start with some basic observations. You can see in here, it also in places is made out of little chunks of rock. Although these are much smaller, I'm not seeing the big, huge clasts or particles that I saw in the mineral fork tillite. So in this little zone here, we're getting, maybe up to marble or slightly bigger size rocks. And if I look at the shapes of a lot of these, I can see a lot of rounding. A lot of these individual little pebbles in here have more of a rounded shape to them than an angular shape. And so here, this might be a little bit of what we call a conglomerate. And you can see, you can trace that across over into other places like over here. It looks like it's very quartz rich. Most of the particles are these very light colored white particles. Looks like it's very quartz rich. But if we move up a bit, it looks like it grades upwards into something a little bit different. It has what I would call like a sugary texture. Again, the unit is quite hard and resistant. And what we have here is a rock that was once a sandstone. This was a quartz-rich sandstone, but it was under so much pressure, probably from the overlying units, that those sand grains are now essentially fused together. If you want to call that low-grade metamorphism, you can, but now it's what we would call a quartzite. So this is actually a quartzite, a low-grade quartzite, I would say. We can still see some of the pebbles and other particles in here. And in other places in the Wasatch Front, we can sometimes see cross-bedding in this unit. Now, I'm not seeing any here, and I might not expect any because there's so much fracturing and the rock is just so busted up that we might not see that very much. But this unit is called the Tintic quartzite. It's Cambrian in age. Again, it's about 530 or so million years old. It makes up all the rocks there up the skyline. Kind of varies from almost a white color to more of a beige, brown, and almost orange color. Anyway, so this is our quartzite unit here, and these have been interpreted as beach deposits. So imagine sand and streams coming into a beach environment. Of course, this was back in the Cambrian when we didn't have any plants on land. Life was still quite primitive and mainly in the oceans. And so this is a beach deposit here. You might actually, there's a little hint here that some of the cross bedding might be preserved in the rock here, but this is actually a beach deposit from the Cambrian. Looks like we have a visitor up here. Do you see? One of the mountain goats is checking us out right there, right at the skyline. Anyway, so we've got this Tintic quartzite. So we've transitioned then, if we think about what we've seen here, we've transitioned from these dark brown rocks that have particles of various shapes and sizes and rock types, this tillite or diamictite from 850 million years ago representing glacial conditions. And then as we move up past this unconformity, this is a big unconformity of probably about 300 million years right here at the top of the ledge, the color change. And then we transition into a beach environment. So we're going from glaciers and ice to a shoreline beach environment over that interval and that contact right there, which I think is pretty incredible. Couple other things we can see up here on top. You might be able to see just how shiny some of these surfaces are. So these diamictites or glacial deposits, again, we've seen all the shattering in the quartzite. These rocks have been folded and faulted during different mountain building events since they formed. And so we can see some of these are fault plains where we have this smooth surface, and you might be able to pick out some of the lines, what we call the slicken sides on that surface, indicating which way the fault moved. Here's a big clast or big particle in the diamictite. And then, oh wow, here's, hopefully those show up really good with the lighting. Here's a whole series of these slicken sides on this beautifully polished fault surface right here. Hope you can see some of the reflection from the sun along that sheared and polished face right there. A couple of the anchors for the rock climbing. And then down here is another really great fault surface, just perfectly polished. In this case, we've got striations across that fault plane running this way, indicating the movement of the fault. So just some really spectacular geology exposures here in Rock Canyon in northern Utah. Thanks for joining me for this fun little video to look at the Precambrian and Cambrian contact here in Rock Canyon, the diamictite glacial deposits, and then the shoreline deposits from the tintic quartzite sitting right above. Appreciate your support of the channel. Thanks so much, and we'll see you next time.